Suppose we ask a class a simple question. What fruit do you like? 13 students like apples. 11 students like bananas. So, how many students like apples or bananas? In math, the word or is inclusive. It means a student might like apples, they might like bananas, or they might like both. In this class, 5 students like both. If we try to find our total by just adding 13 and 11, we get 24. But that basic addition has a flaw. The 5 students in the middle just got counted twice. To find the true number, we add the 2 single groups, and then we subtract the overlap once. 13 plus 11 minus 5 gives us 19 unique students. This is a counting method designed for fairness. For 2 overlapping groups, the rule is straightforward. Include the single groups, then exclude the pair. Introducing a third option, like cherries, makes finding the total without overcounting challenging. Following our logic, we add the single fruit groups together. Then we find the 3 petal-shaped areas where 2 fruits overlap, and subtract those pairs to fix double counting. Look at the exact center. Students who like apples, bananas, and cherries were added 3 times with the singles, then subtracted 3 times with the pairs. They're erased. To fix this, we add the center back. Add singles, subtract pairs, add triples. As overlaps get deeper, the formula requires an alternating plus-minus pattern to keep the final count accurate. A 4-circle diagram is a chaotic mess, so we rely on algebra. Singles sum to 68, pairs to 38, triples to 10, and one student likes all 4. We alternate signs, plus 68, minus 38, plus 10, minus 1. That equals 39. To understand why that final group is subtracted, consider the one student who likes everything. They're in 4 single groups, counted plus 4. They're in 6 pairs, subtracted 6 times. They're in 4 triples, added 4 times. 4 minus 6 plus 4 equals 2. Before that final step, the student is still being counted twice. Subtracting that final group once brings their count down to exactly 1, balancing the entire survey perfectly. At its core, this method is a corrective tool. It ensures that every single individual is represented exactly once, no matter how many overlapping categories they fall into. We can summarize this logic as a universal recipe. You add the singles, subtract the pairs, add the triples, and subtract the groups of 4. The signs alternate, plus, minus, continuing infinitely for as many groups as you have. Because we first include sets by adding, and then exclude the overlaps by subtracting, this exact sequence is known in mathematics as the principle of inclusion exclusion. When you need to count fairly across complex groups, just follow the recipe. Include, exclude, and repeat. You will never leave anyone out, and you will never count anyone twice.